recording just this small space. Algorithm for Fisher LDA assume that we have normal law distribution and the same covariance matrices. Covariance matrices, we will go further to definition in short way. It's like a distribution, but in multi-dimensional space, multi-dimensional variance. So our spheres should be equal shape of the distribution. The theory predicts the solution of the upper algorithm's first step, to define by the criterion. Weight vector should be inverse covariance matrix multiplied by M1 minus M2. What is it? M1, capital M1 and capital M2 being the vectors of two classes average values projected to the projected to this vector. And in this case, covariance matrices, in case when covariance matrices of two classes are not equal, it's better to take average matrix of the classes at the covariance matrix. And we may compare PCA and LDA in some way because they're quite close intuitive. In PCA, we find the axis that maximize the variance, but in LDA, we maximize the component class, the class separation. So it's not depends on variance. So not the same job, but sometimes someone may just think that they are the same. Here we are trying to find also optimal position, but for what? In PCA, we maximize the variance.
Yeah, I know, but both of them they are doing dimension reduction.
No, yeah, LDA. We may say that LDA reduct the dimension because we are going from n to 1.
Yeah, but they are doing like PCA trying to maximize the variance, but the LDA is trying to make the expression
better. Yes, it's like a point. Don't think that they are quite close because some students think that LDA is like a PCA, but for separation. So no, just this slide for someone who don't couldn't differentiate the approaches because names quite close, PCA and LDA.
Does PCA make groups?
We don't have groups inside PCA. How to find the properties for the weight vector? We estimate mean values using usual approach, sum divided by number of elements in each class, and also we calculate variance matrix. It's close to the ordinary covariance, but in multi-dimensional feature space, you will in MATLAB you will have the equation of the function for it, and you will obtain square matrix for covariances between each other, and actually. You will see, you will find this position of the vector maximize the Fisher criterion. It uses mean values of projected classes. If the points of each class objects be projected onto the vector direction, then each x vector will turn into a corresponding scalar y, and shown in the figure. So x we calculated into y value. The average values for the samples of projected points are equal to this equation. So you see that mean value of y's actually mean value of projection equation, because y is weight vector multiplied by x, and we may transfer bad vector before the sum. And this right part of this equation actually mean value for x's. So it will be mean values for projections for the first and the second class. It's vector multiplied by the mean vector of means.
How can I know that this is optimal?
We will go to this. We'll go into this. So just keep it in mind. The distance between M1 and M2 will evidently represent the classes' removedness from each other after the projection. We assume, let's suppose that we express distance between classes like the distance between mean values of the classes in one-dimensional feature space, because we have projections. This distance then estimate the between class distance between class split is given by the expression distance in squared. It's squared because we just remove the sign minus plus and maximize the difference. Yes. So we just actually calculate the square of the matrices as multiplication one to another in transpose way. And in this case, actually, we have also vector out of the brackets. And it will be, this expression is our between class split, SB. Keep in mind, it's like a representation of the distance between classes. In the same way, the sample dispersions, they reflect is within class split. So it's like the width of the class dispersion, class distribution. Actually, just remind you the equation for variance of the data sets. We are using here mean values, which were calculated before, and determine the sample split for two classes in projection. We are using projections now, and in matrix form, it will be like here. So two indicators as well as dispersion serve as an estimate of within class dispersion. The greater they are, the greater the data dispersions. Yes. And the values S1 and S2 can be used to determine average within class split. We just summarize them to express dispersion of two classes. And to determine them in terms of statistical parameters of the classes samples, let's define the spread matrix as G for G's class. It's the analog to correlation matrix in this form. So we just find this spread matrix using distance for each element, how far it from the mean value, and find the sum of square actually transpose. Matrix by transpose matrix, it's a square of the matrix. And calculate the previously introduced equation. Yes. In this form. We just also again one more time introduce new variable spread matrix for the first class, and it will be formula will be simpler for this case. So, and the last step, the weight vector found thus gives a maximum of Fisher's criterion that can be written as this is our distance between classes and dispersion inside the classes. Yes, in matrix form, you may write it right here, like before. So the analysis of this formula suggests that we have maximal value. Maximum value we may calculate using, for example, derivative, something like this, to estimate it. Will be when the vector will be equal to this equation. So actually, in your course project, you need to calculate this value for this criterion for each parameter. It shows you separability of the classes using your features. When you don't have that vector, you may also estimate separability of classes. This value, if you have this value, for example, 10, you couldn't say is it good or not. It depends on the data, but you may compare that if you have 10 and 15, that when the level of the feature criterion 15 classes as better separability on this parameter, then that's parameter with the G value 10. It means that you need to resolve the problem for optimal position of the vector. You need to find the distance between three classes, like a pairs. It's better to do
M1, M1, M2, M2, M3.
yes, but it's better to divide your three classes into two, so to merge some classes into one. Find the solve the problem one time. After that, create feature classifier for these two classes that were merged, and you will have two rules.
So when I have many classes, LDA, not good as this. When we have more than two classes, LDA will be good as
PCA is not about classification. One more time. No, PCA is for projection data space. It's not connected. Yeah. If you have three classes, you need to create two classifiers here. So the bed vector equation, you will have it in lab work, like simple kind of code. In practice, here the algorithm how to estimate the bed vector. You calculate the covariance matrices, estimate some average matrix. It may be sum of matrices. It may be also half of the sum of matrices. Calculate inverse matrix and calculate the bed vector using the formula. And normalize to the length of the vector. Project classes onto a line. Compare it. Find the threshold and create an algorithm. So could you ask me a question? At the end of your lab work, there is a task to declare the algorithm of classification, to write the algorithm of the classification. Could you answer me this question? What you will write in this part of the lab work?
Like the steps, how to
How in the end of the lab work, I will open it.
point the mean which you try to maximize the.
What is classifier? One more time.
I just have a question.
Uh-huh.
BCA, yeah, it won't give us a group, but it can separate the data. So I
No.
can use it.
You couldn't separate nothing, anything without this PCA. You just find the direction of the best variance.
Right.
So it's where is the classes here? There is no
And-
classes, only
I'm
points.
gonna have a new access and redistribute the data.
Okay, but there is no classification here. You classify is something that map your
Yeah, I
input
know.
into classes.
Mm.
There is no classes and mapping input variables into classes. There is no classes. All objects are equal. Like one class. There's no classes.
The eigenvalue is like percentage of each feature in the, the BC1 is about the how, even when we do it on MATLAB, we can have for the lab 4, you would see that the map is about like there is 3 by 3 map matrix, and each column would be like three items. Each item represents the percentage of each feature. Yeah.
This is not the
You
space.
couldn't
I can use it for, yeah, this won't give us like prepared groups, but I can use it for separate.
Pictures is not like classes. Pictures is the important information in this one group of data. It's about one group of data. And what are the important information?
Do you remember this picture?
Yeah.
If you project the first principal component, the first principal component goes like this. If you project your classes into this principal components, you will merge classes. By how you could not know it before use it. So by LDA, you will find the direction for project. It's don't
Yeah, I overthink about things. That's why.
fix it. Yeah. So see, someone just have something in mind that's LDA is similar. Not no.
No, I know it's not similar, but I thought I can use missing.
You may use before, but
We have something before in the lecture.
for which purpose?
It's not possible to taking
Pre-processed data.
the variance. This is why you
Yeah,
separate.
when you took the variance about something, but then, yeah, you may, I'm not saying in one dimension, you took the two dimension or representing the percentage of each feature, so you can just separate it according or regarding to your.
When you identify things, it doesn't mean you make groups or classes.
Sure.
Okay, if you bring something to show about this, will be interesting for me also. Okay, let's look to the practical tasks. You need to find the optimal bed vector using the feature maximum criteria and project classes on the debate vector, create histograms, and find the optimal threshold using the minimum classification error criteria. You will do it manually. You just look to the class, if you will select A is which equal to something, I will have minimum classification errors. But important note, in this example, you may see that there is 1, 2, 3, 4, 5, 6, 7 is not a value of the parameter of the projection. Why? Because here you have plot without T. Actually, in column work, you need include also T value to see real value for the parameter, because you may see that the range goes to 0, but if you select the threshold is equal to 4, it doesn't correspond to the real situation. So you will have misunderstanding of that data set. Keep it in mind. If you do something think what are you doing, because here maybe mistakes.
We have to decide the range of Z.
Yes, in accordance with your data set, with your projections. And the third step is formulate and obtain classification algorithms. Do you have any ideas what you will write here? What does it mean, classification algorithm?
This is the last
Which
steps, word and,
Which do you just?
I don't remember.
Yeah. Yes, suggestions. What is a classification algorithm? What I should do? To which question it should answer? To which question this algorithm should gives us some answer? Okay, remind me the definition of classifier. What is a classifier?
Express our data.
Maps the point from, I don't know what.
It separates the data into groups.
No, definition of the classifier.
Classifier is like foods.
It was 1 hour and a half ago. You don't remember what it was.
Yeah, that's the point.
Which points to what?
Point of the option.
When you recognize the illnesses depending on the symptoms.
The definition of the classifier. Okay, open your laptops or turn on the PCs. Go to the lab work and reread information and materials from the lecture. Find the definition of the classifier in the lecture materials. Answer me the question and think about what is the classification algorithm. Okay. That's all for the lecture. There are two approaches: manual and mathematical. The manual approach is look at the picture and find some points where the intersection. Yes, you will do it manually. Okay. Yes. In the end of the presentation, you will find two links about LDA. Two additional links which may be useful for you. So, step 2. Now we will have a little break. I think that we will return to the class in half an hour, and we will, with you, we will continue with your lab works and your questions about course project and practical task. Okay?
Okay, madam.
Thank you very much. So half an hour to have some rest, and after that, be ready to show your screen or your results or answer or asking some questions. I will be here to answer.